Hello and welcome. In this video, we're going to be solving another mechanics super tough question, which is an idea that comes a lot, and usually every test there is this one question that's super hard for students, and usually they bring an idea like this one. So let's attempt this question. First, let's start by reading the question. By the way, this is from the November 2022 session. This is paper 42, Cambridge. It says 3 particles A, B, and C of masses 0.3, 0.4, and m kilograms respectively lie at rest in a straight line on a smooth horizontal plane. What does smooth tell me? That the plane does not have any friction. The distance between B and C, the last 2 particles, is 2.1 meters, and A is projected directly towards B with a speed of 2 meters per second. After A collides with B, the speed of A is reduced to 0.6, still moving in the same direction. Show that the speed of B after the collision is this. So this looks like a momentum question, and you know in momentum we have the law of conservation of momentum equation that we will use, and I'm going to show you. But first let me tell you what's the question talking about. It says that we have 3 particles, A, B, and C. The distance between B and C is 2.1 meters. B and C are still, and A is projected directly towards B with a speed of 2 meters per second. So let's do our momentum collisions thing. What I like to do is I like to draw my 2 particles, because in momentum you'll always have 2 particles colliding together. So I'm gonna draw the 2 particles. Here the collision is gonna happen between A and B. Okay, I like to write the mass inside. So the mass of A is 0.3 kilograms. This is particle A. This is particle B. The mass of B is 0.4 kilograms. I like to write the initial speeds, or the speeds before the collision, on top of the particles. So A is moving towards B with a speed of 2 meters per second. Okay, and B is basically still. It's at rest, it's not moving. Okay, and below the circle that I drew, I like to write the speeds after the collision. So it tells me that after A collides with B, the speed of A is reduced to 0.6, still moving in the same direction. So in the same direction, but it's now 0.6 meters per second. And obviously, if the collision happened like this, B is also going to be moving in that direction, and we are required to find that velocity. Let's call it V. So the second step in collisions always is to choose a direction. Here in this question it's not gonna matter, but please practice to choose the positive direction so you don't miss out any negative or positive sign or mix them up. So here I'm gonna choose going in this direction to the right as my positive direction, so any velocity pointing that way is gonna be positive. Again, in this question they're all pointing in that way, so it's not gonna matter. However, in other question it does, and it does a lot. So let's write our conservation of momentum equation, which says that mass 1 times u1, which is the speed of particle 1 before the collision, plus mass 2, or mass of particle 2, times the speed of particle 2 before the collision, should equal mass 1 times the speed of particle 1 after the collision, plus mass of particle 2 times the speed of particle 2 after the collision. Let's call this V2 to be consistent. So over here, we're gonna have m1 is 0.3, u1 is positive 2, plus m2 is 0.4 times u2, which is 0. This is gonna equal m1, which is again 0.3, times v1, which is positive 0.6, plus m2, which is 0.4 times v2, and this is what I need to get. So this term is gonna be 0. 0.3 times 2 is 0.6. equals 0.3 times 0.6 is going to be 0.18 plus 0.4 V2. And from here, I can move this 0.18 to the other side. It's going to become 0.6 minus 0.18. That is going to be 0.42 equals 0.4 V2. V2 equals, we divide both sides by 0.4. That gives me a V2 value of 1.05 meters per second. notice that I got a positive answer. A positive answer means that the initial direction that I assumed for V is correct. If I got a negative answer, it means that whatever direction I assigned V, it's actually the opposite direction. Okay, this is super important for you to know. And here it tells us show that B is moving with 1.05, and we did that. By the way, those keywords are super important. And a thing on a side, you know, for mechanics, I have a full course on Udemy. It's called an alternative to tuition. It's designed to replace expensive tuitions that you will pay. The price for the whole year is just a fraction of the price that you would have paid if you would continue tuitions. It has everything from explanations, every single topic for Cambridge and mechanics, solving topical questions on every single topic, solving full past papers at the end, and then a summary section with revision and keywords that you need to know, combining everything. It's a one-stop shop for mechanics to get your required mark. I'll leave a link to it on the top right hand corner. Please go check it out, and if you like it, you can email me. If I have still discount codes available, I'll send you one. Trust me guys, it's worth it. Go check it out. Anyways, so this is part A. We showed that V equals 1.05 meters per second. Now it says after the collision between A and B, B is gonna move directly towards C. We expect that. Particle B now collides with C. After this collision, the two particles coalesce and have a combined speed of 0.5. This is a super important word. Whenever it tells you coalesce or join or combined, it means that after the collision, the particles stuck together and they are moving as if they are one big particle. With the masses combined together, its mass is going to be the mass of the first plus the mass of the second, and they're going to move with just one singular speed. This is super important, and I'm going to show you how to think about it. First, let's draw again our momentum circles. Okay, so we have particle B, particle C. Particle B is moving to the right with a velocity of 1.05 meters per second. Particle C is at rest. Particle B is 0.4 kilograms, I believe. Yes, 0.4 kilograms. And particle C has a mass of m kilograms. And then they both combine and move with a combined speed of 0.5 meters per second after the collision. So right here, we're going to just have a slight change in our conservation of momentum equation. It's going to look like this. m1 u1 plus m2 u2 is going to equal, again, m1 plus m2 times v. This is me saying that it's just going to be a single term, not two terms like here. It's just going to be a single term with the masses combined and moving with a single velocity. So again, I'm going to choose right direction as positive. m1 is 0.4, u1 is 1.05, plus m2 is just m, u2 is 0, so this term is going to become 0, equals m1, which is 0.4, plus m2, which is just m, times the combined or the shared velocity that they move with together. It's actually combined velocity, that's the right term, 0.5. Okay, so from here, what I can do is I can say that 0.4 times 1.05 is basically 0.42, equals 0.5 times 0.4 is 0.2, plus 0.5 times m, which is 0.5 m. Moving the 0.2 to the other side and subtracting is going to become 0.42 minus 0.2, which is going to be 0.22 equals 0.5 m. Divide both sides by 0.5. You will get your answer as m equals 0.44 kilograms, and this is the correct answer. Now, these parts are fairly simple. They're super simple. This is where I want you guys to focus with me. So let's read and think about this. C tells me find the time that it takes from the instant when B and C collide, so from the second collision, until A collides with the combined particle. Okay, let's think about this. Okay? So what happened was we had A, B, and C. A moved towards B and they hit each other. Okay, and now this is the first thing that happened. Now what happens is A is here, okay, and it's moving to the right, and B is also here and is moving to the right. After the initial collision, A was moving with a speed of 0.6 and B with a speed of 1.05. So this is 0.6 meter per second, this is 1.05 meter per second. And this is particle C. We know that the distance between B and C was 2.1 meters. Is it 2.1? Yeah, 2.1 meters. So the distance from here to particle C, this is B, particle C is also 2.1 meters. Now, what happens is B is moving faster than A, so it's gonna reach C before A reaches C. That's logical. It's gonna combine with C, so now it's gonna hit C, okay, and they're gonna move together with a speed of 0.5 meters per second. So I need to think about the time it took for B to move from here until it reaches C. Obviously, A was not standing still. A was not doing nothing. A was also moving. So what I want to know is, where did A reach? I need to know, where did A reach when B and C collided together. So to know that, you know that the time that will pass for B until it reaches C is going to be the same time that I'm interested in, because if it took, let's say, 1 second, okay, then I want to know in that 1 second what happened to A. Where is A? So first, let's start by finding this time. Now, this is a case where we don't have acceleration, and by the way, we don't have acceleration because the surface is smooth. So what creates acceleration? You know that F equals ma, right? So if there is sigma forces, if there is a resultant force, then there will be acceleration. However, if it's smooth, what do I have? I just have the mass, and it's gonna be balanced by the normal. Left and right, I don't have anything, right? If I had friction, then I will be having a sigma force. I'll be having some force which is gonna cause some acceleration. However, here, since there is no friction and there is no pushing force, there is nothing. So the ball is not gonna experience any acceleration, so it's gonna keep on moving with a constant velocity. This is just an important idea for you to understand. So if it's moving with constant velocity, we just use the simple equation, velocity equals distance over time. So let's see how much time it took for B to reach C. So the velocity of B was 1.05. The distance that B moved is 2.1 meter, and we're interested in the time. So time is equal to 2.1 over 1.05. This is going to give me a time of 2 seconds. So now you're telling me that B took 2 seconds to reach C, right? So let me see in those 2 seconds, where did A, how much did A move from here to where? A is probably somewhere over here. Yeah, so I need this distance. I need to know this distance. So again, we can use V equals D over T for A. So this was for particle B. Now for particle A, we have 0.6, which is the velocity, equals to some distance that we don't know, but we know that time that we're interested in. So the distance is going to be 0.6 times 2, which is basically 1.2 meters. All right, that tells me that at this moment where this is particle C, B reached C, okay, now A, from the starting position, A moved 1.2 meters, right? So this A is here now. When B is here, A is here. That means that the distance between, at this exact time when the collision happened, the distance between A and this collision is going to be 2.1 minus 1.2. It's going to be 0.9 meters. So at this instant, which is 3, I have A over here, B over here, and C over here, and the distance between A and B, or A and BC basically, is 0.9 meters. A is moving with a constant speed of 0.6 meter per second. B and C, they're moving with a constant speed of the combined speed. Remember, they were moving with 0.5 meters per second. Now A is moving faster than both of them, so obviously A is gonna catch up with them. So let's say let's do it with a different color. Let's say all the way over here, this is particle BC, and this is particle A where it catched up with them. Let's call this distance from here all the way up to there some distance x. We don't know it, right? We don't know this distance. So let's now use the and this is the hard part, knowing this. What I know is just the velocity. I have to use it. What is the equation for constant velocity? V equals d over t. So let's try that for particle A. For particle A, the velocity is 0.6. The distance that I'm interested in is this distance x over the time it will take. I don't know how much time it will take. Let's call it t, right? This is for particle A. For particle BC, their speed is 0.5. Their distance is going to be what? They're going to move this distance, right? Only this period, which is basically x minus 0.9, correct? Because this whole x, remove from it 0.9, you end up with this distance. So x minus 0.9 over, it's going to take the same time, right? Because they're going to hit at the same time. So the same time that has passed for A until it catches up is the same time as has passed for the particle B and C. So we use the same time. Now we have two equations, equation 1, equation 2, and two unknowns. We can use that to solve. So we're interested in what, the distance or time? It says find the time it takes from the instant B and C collide. Okay, so we're interested for time. So something useful that we can do is we can say multiply this t over here. So 0.6t equals x, and then substitute it in this x. That way we eliminated x from the equation. So we're going to have 0.5 equals x, which is 0.6t minus 0.9 over t. Multiply t both sides. This is going to be 0.5t equals 0.6t minus 0.9. I can move this 0.6 over there. It's going to be 0.5 minus 0.6. That's negative 0.1t equals negative 0.9. Divide both sides by negative 0.1. I'll get t equals 9 seconds. And this is how to solve this question. This is how to get this question. So the idea is, when it tells you some arbitrary distance where they will collide, the trick or the experience will teach you to just assign it a random variable. This green part is what made me solve the question, is that I said, okay, they're gonna meet at some distance. I don't know what's that distance. Let me call it x, and then start from there. So this comes with experience. And by the way, in Cambridge, they bring a lot of questions like this. So this idea is super, super important to understand, okay? And I have a lot of other ideas and a lot of questions similar to this one as well that I'm going to solve very soon. But please, so you don't miss them out, don't forget to like, comment, and subscribe down below so you don't miss out anything. If you have any questions or suggestions, leave them in the comment section down below. Thank you so much for watching, and have a good day.